In this video, we're going to use another method to determine the rate law for a reaction. And this time we're going to use the pre-equilibrium approximation, because we're given that step 2 is the rate determining step. So it's the slow part of the reaction. So therefore we can write our rate law based on this step. So this would have a rate constant K2 multiplied by the concentration of B. And given that B is an intermediate, this is not our final rate law. So in this case we need to use an approximation to replace the concentration of the intermediate B. So first we're going to label the rate constant in the forward direction of step 1 and the rate constant in the backward direction of step 1, given that this is an equilibrium elementary reaction. So what we'll do is assume that equilibrium is reached quite quickly, and therefore we can write K1F multiplied by the concentration of A squared. Okay, so A is being consumed in the forward direction, and A has a stoichiometric coefficient of 2, and this rate law is equal to the rate law in the backward direction. So that will be K1B by the concentration of B. So what we've done here is assume that the rate at which A is consumed in the forward part of the reaction is equal to the rate at which B is consumed in the backward part of the reaction. And now we can solve for the concentration of the intermediate by dividing through by K1B. So we get K1F on K1B multiplied by the concentration of A squared. And now we can substitute this in our rate law. So what we get is K2 by K1F over K1B by the concentration of A squared. And this here is just another constant, which we'll call K. And therefore the rate law for our reaction is equal to the rate constant K by the concentration of A squared. And this is the same result that we got using the steady state approximation in the previous video.